Hi, everybody. Welcome to a brand new episode of the Clear to Send podcast. I'm your co host, Roel Dionisio, alongside your other co host, Francois. How are you doing, Francois?
Very good. Hero, how are you?
I'm great. And we have a great episode today where we're going to talk with Austin from Nile, who's going to give us an introduction of what Nile is, what they do, what does Austin do. I'm actually interested to hear more. So, welcome, Austin, to the show.
Thanks, guys. Great to be here.
Yeah, why don't you introduce yourself to everybody and also introduce Nile, the company?
Yeah, thanks, Ron. So, as you mentioned, Austin Hawthorne, I run the pre-sale solution architect team here at Nile. Been with Nile for a little over 3 years now. We'll talk a little bit more about the company when I get into a little bit of what Nile does. But a little bit of background, I've been in the network security, and cybersecurity industry now for the better part of 25 years. Mainly on the vendor side of the house. This is actually my fourth startup vendor. My last one that I was at was Aruba Networks. You guys might know those folks. Started out as a WLAN company back in early 2000. I actually joined that company when it was just 50 employees back in February 2004, and went on a nice 17-year journey through IPO and acquisition. And we're looking to do that. That if you think back at wireless back then, it was really disruptive. These new startups like Aerospace and Aruba and Maru and Trapeze and all those guys really trying to bring true mobility to what was a network that wasn't built for mobility, right? With these controller-based architectures and everything else. And that disruption won out, right, for a number of reasons as it relates to, use cases, security, business agility, what have you. Those types of architectures were really needed to bring those types of outcomes to customers. And what we're doing here at Nile is very similar, right? It's all about customer pain points. And if we think about networking, that's and how customers consume networking today, it hasn't really changed fundamentally in the last 3 decades. As I mentioned, I got into networking, or at least on the vendor side of the world, 25 years ago, but I've been in the networking space probably for 28 years. And right around the time when Ethernet and IP became the de facto standard, right? Cisco was the big, incumbent vendor out there. They kind of won out, and they kind of really created this industry that we've all benefited off of. If you think about how customers consume networking, though, and when I make the comment about how it hasn't fundamentally changed, ultimately customers have to go figure out what technology they need from what vendors as it relates to the wireless LAN side, the LAN side, the distribution, the aggregation, the routing, the data center. What do they need to do from a network management perspective, network access control, visibility, what type of architectures they're going to put in. They've got to go buy something or a lot of something, and they probably can't afford everything they want, so they got to make some trade-offs and compromises. They've got to then have either expertise, a lot of CCIE level people on staff or hiring them or outsource it to try to go figure out what to do with that technology to meet their business needs, as it relates to their agility, their growth, their scale, their use cases, their security challenges, whatever. And those business requirements are constantly changing, right? With new users, new devices, new threats, new needs, new applications, whatever. And they have to constantly figure out, can I make this network do what I need it to do at the pace that I need to do it with? And do I have the budgets that I need to be able to do it? Do I have the talent that I need to be able to do it? Do I have the time? Right? And a lot of that, if you think about the cost and complexity that is networking, all those different pieces and parts that have had to been bolted onto the network over the past 30 years to meet today's, use cases, security threats, and challenges, it's a lot. And most organizations, I would say, don't have the budgets, don't have the big teams to ultimately figure out how to extract the true value out of all the complexity that is today's networking, right? To ensure that they're actually able to meet their business needs at the pace of their business, because it's just gotten too complex. Think about, I use a common analogy when I'm talking to customers and partners and, in events like this. If you think about a network engineer like me, and by the way, when I got into the industry 25 years ago, I got my CCIE. That was the way to get into this space, right? It was a great, launch point to kind of, get into a great career. But if you took network engineers like me, you put 100 of us into a room, and you said, hey, listen, here's a blank sheet of paper. I want you to design me a network, and everybody gets the same requirements. It's got to satisfy these 10 use cases, whatever they are, right? Security, visibility, voice over IP, quality of service, whatever. It doesn't matter what they are, but everybody gets the same 10 use cases. But and they get to design it any way they want. But they've got to fit it into this budget envelope, and they need to be able to hand it off to operations so operations can support whatever they've built. How many different designs do you think I'd get out of that room of 100 different network engineers? At least 100, right?
100
Me
to
personally,
1,000.
I probably put together, yeah, I probably put together 10 different designs with a bunch of what ifs. Well, if you want this, you got to trade off this or do this,
Exactly.
right? So it leads to an environment where there's a lot of snowflakes, a lot of, no customer environment is the same. And if you have all of these snowflake environments, how does anybody have any chance of being able to, automate a lot of tasks, throw AI tools out of it, get any kind of scale, get any kind of agility, get any kind of, environment that they could truly scale with inside of their organizations? And that's what Nile's all about. That's why I came to Nile about 3 years ago, because we said, listen, solving this problem, and I'll pause here in a minute, just giving you the background, but solving this problem, a lot of traditional vendors and a lot of vendors that are supporting traditional vendors are saying, hey, AI and automation is the solution to this problem. Think about automation for a second. Automation is yet another component that has its own cost complexity that is going to sit on top of this cost complexity, which is today's networking, right? And if every environment's a snowflake, how do I build a common data structure with a common log format, with common software versions and everything else? How do I purchase that tool, afford that tool like Ansible or whatever it is? How do I get expertise on staff, and can I afford that expertise on staff that knows what to do with that? How do I get everything into a common data lake? And then how do I determine what are the problems today, tomorrow, and in the future that I need to constantly tune this thing? It's just more cost complexity on top of cost complexity. We basically said, listen, there's a better way to do this. If you think about what happened 15 years ago, there was a big wave of disruption. Amazon Web Services said, hey, the same problem that I'm talking about with networking, they were saying the same thing with data center. So all the same problem statement. Customers can't get the outcomes of the technology. The way they consumed it is just not working, and they need a better way. And Amazon said, stop buying, building, and operating yourself and not realizing the outcomes. Instead, consume it. And we'll build a purpose-built stack that delivers predictable outcomes at scale, that frees you of all that cost and burden, right? And you can now, but I'll give you the control and the visibility you need to do what you want to with that technology. And that technology will always have the scale, security, and capability you need at the pace of your business, right? And they built a purpose-built stack. You know which area of the technology stack has not been fundamentally disrupted like that? Networking.
Yeah.
Right. So we basically said, and by the way, a little bit of a background, I'll name drop a little bit. John Chambers, I think we all know John Chambers, right, from Cisco. And his right-hand man that made Cisco, Pankaj Patel, who was running the majority of the business for him, during those glory days of Cisco, are our co-founders. They said this space is ripe for disruption. Customers are looking for those true as-a-service type outcomes in other areas of the technology stack, and networking is ripe for disruption. And an incumbent vendor with all this tech debt is just not going to be able to do it. So we have to start from the ground up to be able to deliver those types of outcomes to the customers.
Yeah, and I agree, because when we look at automation and how we've brought automation to networking and even how it's coming into the Wi-Fi world, we not only just have network engineers, but now we have automation engineers or net DevOps people, and we're just adding more people to the team, because you've got those who understand the network side of things, but then those who understand the automation side of things. And I think it's a rare breed to find someone who can do both very efficiently and that's very good at it. I do run into a lot of people who are just very good at automation, but they need a little bit of additional input on the networking side and what you need to get out of the automation piece. I mean, it's good teamwork, but it does lead to more time consumption on the tech stack that you have to build around that, the tools that you have to include. So now you got to find someone who's good at the Ansible part when maybe that wasn't really the goal, but you need to automate it. So that's a tool that you find. And I think that is a big challenge right now for networking, and even for smaller networks where they don't bring on a dedicated network engineer. It's just someone who has an IT role, but they do want to automate because they don't want to focus on the network. They just want to turn it on. It works, but they still want to get a lot of benefits out of the latest trends right now, which would be automation and AI.
Yeah. And if you think about it, I mean, that, any kind of disruptive tech usually comes into the market and addresses an underserved part of the community, right? And all this complexity that I'm talking about, it's really the top 1% of the organizations that are going to have the budget and the big teams that are able to kind of keep up with all of this different innovation that's out there. There's a big innovation gap between what's out there and what most customers are actually able to afford, consume, and realize the value out of. Right? It's not that the technology doesn't exist, but do I have the budgets and do I have the teams and do I have the time to actually realize the value? And Nile's approach is almost, for all intents and purposes, democratizing that technology for the masses, right? To the point where you can actually realize the outcomes without having the big budgets, without having the big teams, but you still have the same problems. It's not that they have any less problems. Everybody has the problems of, you know, the network's always to blame. The network's always the fault. The network's slow. The network's broken. I could use some more colorful language, but we all hear that, right? And the network's always to blame. There's always too many tickets. There's always too many patches. There's always too many upgrades. There's always too many, new business, IT business initiatives, right? And there's never enough time, never enough budget, never enough resources to keep up. Something's got to give. And excuse me. One of the things, I just did a presentation at Gartner. I was at Gartner down in Orlando a couple months ago, and I did a presentation, and it was all about automation. The Ansible that you talk about. Think about, and I'm not going to bring up a slide here, but if you can visualize this, and I'm sure everybody listening can visualize this, think about the components that it takes to build a LAN and WLAN part of the network, which is where we're focused today. You've got your AP of choice and, its hardware version, its software version. You got your access switch of choice with its hardware, software, distribution switch, aggregation switch. You've got your network access control. You've got your network management platform. You got your visibility or profiling tool. You got your patch management, your config management. You got all these different pieces and parts, right? And if somebody comes in today and buys Ansible and says, okay, I'm going to figure out how to automate half of my manual network tasks. That's my goal. Just get half. Right? Gartner's got a study that talks about how, I think I'm going off memory here, so apologize if it's wrong. We can clarify, when I send it to you guys. But that 70% of automation initiatives fail to reach that goal of even automating half of the manual tasks. Think about all those different pieces and parts. Even if I take a snapshot in time and I can solve that today, what if I need to patch one thing? That WLAN AP system, right? The access switch system. And all of a sudden the log format changes or something else changes, right? Who's keeping up? And by the way, is one hand talking to the other hand? And it's almost impossible, I would say, to actually try to automate that snowflake world.
Yeah, and I feel that when you get into the automation piece and you're bringing it in-house, you've got a team. Over time, that all becomes in-house tools. These are all tools that you build and maintain. And then as people leave, everyone knew that that person who left was the owner of that system. There wasn't enough documentation. No one knows how to do what that person did, or maybe you didn't backfill and get the skill set required. And then that's when you start looking to go, what tool can we get off the shelf that'll replace this? And I remember talking to someone who ran into that problem. They had a tool that was working for a good 10 years until that person left. And now they're kind of in a stuck position and now have to spend cycles trying to figure out what to do from there.
Yeah. And, while we're on the automation topic, and I know we want to talk a little bit about security, but, there's a famous quote out there, I think it's Elon Musk, right, that says that, the dumbest mistake that very smart engineers make is automating something that should just be deleted. Right, think about that. Like all the different variables that exist in the network today, do I need to automate all of that? Or do we need to just clean some of that up and get rid of some of it? And that's the approach that Nile took. I talk about, how we built this purpose-built stack to deliver predictable outcomes at scale. I couldn't just take off-the-shelf networking, white box, Cisco, Aruba, Extreme, Juniper. I couldn't do any of that and just throw software at it. Because I'm dependent now, or I'm inhibited now by all the complexity that's in their network operating system. Right? All the different protocols, all the different features, all the different configs, all the different logs formats, all the different patches, et cetera. I wouldn't have any better outcome than anybody else. So we had to build our own Nile network operating system. It's a cloud native network operating system that runs on our own hardware. It's like an Apple ecosystem. We tightly coupled the hardware and the software together to deliver those predictable type of outcomes. And one of the first things we did before we started coded anything was said, hey, before we start building this software and building in the automation and the AI and the analytics and everything else to detect problems, resolve problems, and deliver this type of outcome and scale to customers, what can we first delete? What are the top, 100 issues that plague network environments today? And can we first start with deleting as many of those as we possibly can, right? One of those is config. There's some studies out there that say 65% of the source of the root cause of network infrastructure related issues is config. Right? I'll give you an example. One of our customers, a university, is they were on a Meraki solution. They came to Aruba at the final straw that broke the camel's back is they were troubleshooting for 3 months through varying levels of TAC. Cisco TAC, having to provide logs, having to turn on debugs, having to wait for the problem to happen again, having to replicate. You guys probably know how this goes, and the listeners probably know how this goes. You're going through multiple different level 1, level 2, level 3 engineers, and 3 months later, they finally get to the person that says, "Oh, you're missing the CLI command," and as soon as you put that in, the problem goes away. Right? I'm like, it's crazy. So what if we could start with just getting rid of the config problems? And by the way, we're going to talk about security here in a minute. Think about config from a security threat landscape perspective. It's an attack surface, right? I could do all this cool stuff with authentication and NAC and segmentation, everything on my wireless LAN and LAN side of the house. But if somebody gets into that config because there is per network element config, they can bypass those security controls, and there goes your security, right? So now I've got to lock it down with TACACS, and that's yet another bit of complexity and role-based access control and all this auditing. What if I just get rid of the console ports, the telnet, the SSH, the web UI, the CLI, the actual golden configs, the config management? What if I just build the software to interpret your intent and put the right configs in the right places just by the nature of the software? What if I get rid of the need to bring up OSPF? What if I get rid of the need to put IP interfaces and helper addresses and route redistribution? What if I just build a purpose-built stack that brings itself up?
Can you do that if you interconnect with other vendors?
Yeah. So, Francois, let me give you an example. Great question. Mm-hmm. And by the way, for the listeners, we didn't prepare that question, so I love the leading question as well. But so if you guys can imagine, I'll try to paint a picture. Our focus today is on the LAN and the WLAN side of the house today. So we build our own access points, access switches, distribution switches, and sensors, right, that act like clients to measure the network performance, do some proactive testing. That's part of what we call our standard kit. That's our Nile service block. Northbound of the Nile service block, we uplink into a customer's environment. We can uplink into their core routers, or from a security perspective, and again, we'll touch on this later, there's a great capability if we uplink into firewalls. Right? Now, no matter what we uplink into, it's a routed link, a native routed link. There's no special protocols, no special tagging, no extra complexity. It's just a standard /30, a bunch of /30s for redundancy. The customer's IP addressing, we don't control the IP addressing. All of our network elements, because we got rid of config, is just a QR code scan. So let me paint a picture about how far we've gone with no config and integrating a customer's environment. We ask a customer to set up OSPF facing us. Just default, do a default originate into us, and that's it. As long as they don't set up OSPF authentication, and we'll get to that in a minute, but as long as they don't set up OSPF authentication, the installer that goes out and installs the Nile equipment, the first device that integrates or connects to that firewall router, they do a QR code scan. It activates that device against the customer's tenant. Inside that customer tenant, the customer would have already put the /30s that I'm going to use. That gets sent down through that phone and via Bluetooth securely sends a little bit of provisioning information into that switch. It takes that information, it brings up the link. Now we start listening to the hello packets coming from the peer router or firewall, and as long as OSPF authentication isn't set up, I learn enough through those hellos that my stack brings itself up, forms a neighbor adjacency, and starts exchanging routes. No config. Nobody has to go onto my box and configure OSPF to create a neighbor adjacency, which means no mistakes. which means no complexity. Now, if they have OSPF authentication, they have to give me the key because I can't snoop the key. But the picture I'm trying to paint here is we've eliminated that complexity.
So staging initially, someone just uses their phone and a mobile app to get it all up and running, and the initial from the dashboard, it'll push that to the device, whatever that is, the switch.
The way that this service is built, we went to great lengths to automate as many day zero through day end tasks as possible. And by the way, going back, and I gave you a couple examples, we want to eliminate a lot of complexity first, but then we wanted to automate a lot of those day zero through day end tasks. The way, and I'm going to give you a grossly oversimplified kind of view of this, but the way that a customer onboards to a Nile service, they get onboarded to our tenant, their tenant, right? They log in, they tell us the address they need networking, they upload a floor plan, and that's when our automation starts to kick in. That gets pulled into our automation software. We automate a work order to dispatch somebody to do a survey. If you guys think about doing a survey in a traditional way, somebody's got to go into every closet with a scratch pad, jot down, hey, I got a 2-post rack, a 4-post rack, I got this many rack units, I got this much power left, I got these types of power cords, this type of copper cables that are horizontal, this type of fiber going to vertical, and I got to take all that and build a Visio and then build a BOM and do all this other stuff, right? What if you took that data and put it into an app, which fed that structured survey data into our data lake, where we could then use that data in that structured form to automate a high-level design, extrapolate that from that, the low-level design, the connectivity, this plugs into this with this cable and this SFP, which extrapolates that from that a bill of materials that we then ship to a customer, right? And then when this equipment shows up at the customer, there's an automated work order for each one of those network elements sitting in the installer's app, which is the same app that was used for the survey, where they do an activation, just a QR code scan of each and every one of these network elements. And by the way, as they're activating them, that automated high-level design, low-level design bill of material, that's essentially a digital twin that's sitting in our automation software. So as these devices are activating up and starting to talk back to our tenant or the customer's tenant, we're starting to notice, are things connected the right way? Are they placed in the right places? And if not, that's a deviation from the ideal state, which is the digital twin. And let's automatically flag to the installer, you didn't plug this into the right switch or with the right cable or to the right port, which means my redundancy is not as planned and this isn't as planned. And it flags it right away to make sure that the as-built state is the ideal state that was originally planned. And a lot of that is, we can achieve that. I go back to my Snowflake conversation before. We don't, even though we build our own hardware, we don't sell APs and switches. We sell a service. We think one of those things we wanted to eliminate was the trade-off of trying to fit a bill of materials into a budget envelope, that big CapEx spend in the beginning. Can I afford the best AP or just a middle-of-the-road AP or the low-cost AP? Can I afford as many APs as I need to do a high-capacity, highly resilient design everywhere? Can I afford to upgrade my access switches to do MGig, to every AP so I don't have any bottlenecks and I don't need to put a bunch of QoS everywhere? Can I afford all that, or do I have a bunch of trade-offs, right? We wanted to get rid of that, right? Let's just buy a service, square footage or user base, tell me the site, give me the floor plan, and we'll go put in a standard high capacity, high resilient, highly scalable design everywhere. Eliminate the snowflake. And if I can eliminate the snowflakes where everybody's running with the best capable APs, with the best capable switches, with the best resilient type of architecture everywhere, now I can actually automate or bring updates and optimizations and fixes to all my customers at scale because they all look the same from an architecture perspective.
How did you guys automate the Wi-Fi piece? Because different buildings will have different environment, and the Wi-Fi design might look very different if you're talking about an office space or a warehouse or multi-tenant building. How did you guys approach that problem?
It's a great question, Francois. So when a customer onboards to us, the first step we ask is not just this, building address and a floor plan, but we ask them, and I mentioned the pricing and square footage of the user. We ask what type of building. Is it a warehouse? Is it a carpeted office space? Is it a dorm? Is it whatever, right? And one of the tasks that gets, the automated task that somebody has to do is we do a predictive plan, right? And then that predictive plan, and we use Hamina or Ekahau, that predictive plan gets uploaded back into our software. right? And then we dispatch somebody, it's another automated work order, dispatch somebody to go validate that RF plan, right? As part of that application I talked about, that structured survey data, as well as walk all the IDFs and MDFs to feed that back in, right?
Is that in-house, or do you guys have partners to do this?
Both.
Okay.
We have, so this stuff is relatively straightforward and simple. Again, we got rid of a lot of complexity. So we do have our own services. Partners, we have certified partners and a certification program that partners can certify on this and do this themselves. Even customers can do this themselves.
Mm-hmm.
Again, I don't necessarily need a CLI person to go in and install a switch or AP or whatever. It's just a QR code scan. And if the customer already has capabilities to do Hamina or ECHO type RF plans, a part of our standard design, we just give them what our design parameters are. Our standard design, for example, if we focus on wireless LAN, let's just focus on carpeted office space for a second. Our standard design, because one thing I haven't touched on, because this is a service, we want to deliver guaranteed performance-based outcomes to our customers. We back that up with performance-based SLAs that we measure from the client's perspective. Remember those sensors I was talking about?
Mm-hmm.
We measure from the client's perspective, is the network giving me the coverage, capacity, and availability I need to do my business goals, my business needs, right? And it's one thing to measure it from an AP and an uptime, which is the normal way, but we all know that that's not the point of view that the clients have when they're connected in a network. So these physical sensors is where we're measuring those SLAs, and it's one of the many things that these physical sensors do. But because we're delivering performance-based outcomes, we want to make sure that the wireless LAN is designed in such a way to deliver that level of performance, capacity, resiliency, et cetera. So our standard design is neg 65 dBm secondary coverage in a carpeted office space environment everywhere. We don't have the concept of, hey, we just need coverage here, right? It's, hey, let's stop with the trade-offs and compromises, and let's go put in the capacity and the resiliency and the capability in everywhere. Let's eliminate the snowflakes. There is no upfront CapEx, so you don't have to worry, Mr. and Mrs. Customer, can I afford the big spend up front to go put in this really robust design? We're going to do it anyway. The advantage from a Nile perspective is by me putting in this robust design everywhere, it allows me to then deliver those predictable outcomes at scale because everybody looks the same.
Now,
right?
would those
Even though I'm
sensors
spending
be
a little
able
bit more.
would those sensors be able to feed into the wireless LAN controller portion and say, hey, this is the kind of config that needs to be changed in order to meet those performance-based metrics, like change a data rate or change any other config on the SSID?
Absolutely. Absolutely, Raul. And I'll give you a couple examples. These sensors, by the way, they're doing, for job one is measuring the SLAs. And by the way, if you think about those SLAs, the coverage, capacity, availability, for all intents and purposes, it's a 24/7 by 365 RF site survey. Think about how many customers every couple years have to spend some time or spend some money to get somebody to walk around the buildings to figure out if Wi-Fi is still propagating the same way and providing the same level of service as it was 2 years ago. That's a very common thing that a lot of customers have to do, right? Because they only have ceiling level visibility. They don't have what's going on down at the user level. Job one is these things doing that every day, every minute, every year, right? So we know exactly when something changes in the environment and how it might have impacted the user connectivity. And by the way, to your point, Ro, that might mean, hey, somebody just put up a cubicle wall or a new rack or a new whatever in this environment. I was talking to a retailer that literally said, the real estate portion of the business wasn't talking to the IT portion of the business. They had a store that wasn't performing well, so they sold off 2/3 of the real estate, right? But they didn't let IT know. And when they sold off 2/3 of the store, they put up walls to partition out for the other who they were subletting it to, but they didn't move the APs. Well, guess what? The service that was being provided to the point of sale machines in their portion of the store, the only 1/3 that's left, was starting to suffer. And it wasn't until users in the business started complaining, they were like, oh my God, somebody put walls up. So these sensors bring that visibility real time. And right away, we're going to know that something's happening and we've got to do something about it. Whether that's something in software to raise a power level, change a channel, whatever it might be, or whether that's something like, hey, we need to add an AP or move an AP to bring that performance capacity back up. I'll give you another example. The other thing that these sensors are doing, though, and I don't want to get to a real world type of example where there's some automated kind of tuning that goes on inside these environments. But these sensors are also doing proactive synthetic tests to not only the network infrastructure and is it providing that service I talk about, but we all know the network gets blamed on everything. So what if we can automatically test, is the DHCP server available and is it responding quickly? Is the DNS server, same thing. Radius server, same thing. Connectivity outbound, same thing. What about the applications that the users are using on a day-to-day basis? Are they available and are they responding well? We had one customer that literally Facebook went down. If you guys remember, you might not remember, 3 years ago, Facebook went down and it was in the news. It was down for 4 hours and the world was in an uproar. Well, we were in some of our early, trial customers, and one of the customers was like, hey, the network's down. All my users are complaining. We log into the portal, we show them everything's green except the one application test that we're doing against Facebook, and it was red. But it wasn't in the news yet, and nobody trusted us, and they were just pointing the finger at us until 4 hours later when it was in the news that Facebook was down. The users blamed the network when they couldn't get to the application. So what if this proactive visibility can let the customers know, hey, here's where the problem is. Don't wait for users to complain. Go focus your time and attention where the problem is versus where the problem isn't. And that dramatically reduces the time to detect and resolve issues elsewhere. But the one example of tuning I want to kind of mention, we all deal with, I'm sure you guys deal with, and a lot of people listening on the call deal with, these wireless client driver issues and interoperability issues and what have you. One of our customers had older Intel chipsets coming into the environment. And these older Intel chipsets, I forget whether it was 11K or 11R, it didn't like one of those information elements being broadcast to the beacon. And if it saw that information element, it would not connect. It wouldn't even try, right? Think about troubleshooting that, how long it would take, and think about what the traditional remediation action would be. Well, let me just turn off that information element everywhere because I don't know where these devices are going to show up, right? What if we could fingerprint these devices, see that they're coming into these environments, and dynamically tune the system to turn off that information element in the areas where those devices are when they're there, as opposed to just doing a broad brush stroke? Now I'm doing real-time optimizations for interoperability and performance as opposed to waiting for a bunch of users to complain and then just turning off a config, because I just don't have the visibility and I just can't keep up with all of these changes in my environment.
And that's based
when I fix
on
that in
sensor
customer
being there?
Sensor and things that we're doing in the APs as well. And because of the architecture we put in place, because this is locked down, when I fix that issue in customer one, I can roll out that optimization to all of my customers because our software updates are much like a SaaS delivery model where I can roll it out to everybody, right? And everybody gets the benefit of that optimization. There is no more bug scrubs or keeping up with patch versions and doing updates and waiting 2 years to get the advantage of some bug fixes and everything and optimizations and reading validated reference design guides. The software tunes itself because I got rid of the snowflakes and I created this native cloud delivery model to bring these optimizations to everybody.
How do you balance that with, let's say, the organization trying to move forward with security and trying to go with WPA3, but then you have devices that just fail because it's a whole new security protocol that they don't support? Like, I wouldn't want the automation to just turn off WPA3 and just re-enable WPA2. Would you be able to have some control over that?
Yeah, we're definitely not going to do something like that. We're not going to turn off WPA3, but that gets into a conversation with customers. We're deploying customers every day, and we're having those conversations around. If you think about Wi-Fi 6E, if a customer wants to use 6 gigahertz, WPA3 strict mode is required, right? And we have to have those conversations about what does that mean from a legacy interoperability perspective, and do you still need a bunch of devices connecting with WPA2 enterprise or WPA2 pre-shared key because they're not going to support WPA3. So they might have to have multiple SSIDs. This isn't a magic pill for everything. Some of those design considerations still come into play.
I want to go back to the sensor piece. For one, I want to go work for that company that all they do is use Facebook. If that was the only complaint and they figured that, oh, the network's down, but it was really just Facebook, then that's all they're using. But it sounds like the sensor piece is a separate hardware. You're not doing an AP as a sensor. And does that mean you're making part of the requirement in an environment to deploy sensors everywhere? and at
It's
the
a great
end user level?
It's a great question, Roel. So for those of people that are watching on video, this is the sensor. Right? There's just a little wall-mounted kind of sensor, if you guys can see that. But the physical sensor is part of our standard kit. Again, there's no capex, there's no upfront spend. It's just part of the kit. And we do want these sensors deployed because it does give the outside-in perspective of the connectivity, right? But it's not an absolute requirement. Beyond these physical sensors, we have virtual sensors that are in our APs and switches that are also running these proactive tests. If you guys think about normal network troubleshooting type of approach, you want to do that halvesies type of thing. Is the problem over here or over here? Once I determine it's over here, let me further break it down and everything else. So while the physical sensor is doing some tests, we're also doing tests from the the virtual sensors on the APs and switches to determine, hey, is this an environmental thing between the sensor and the AP, or is it something actually with the application network service or whatever? Right? So I have to have those virtual sensors doing part of those tests alongside these physical sensors. Now, in some environments, these physical sensors don't make sense, right? In a hardened, ruggedized, manufacturing type of environment, warehouse type of environment, distribution environment, it might not make sense to put them there. I will tell you, in some dorms, when students might look at these things as hockey pucks, it might not make sense to put them there, right? Even though they have locking down capabilities and all this other stuff. But when these things aren't there, the virtual sensors in the APs and switches make up for it. Now, it's not going to provide, the client's point of view, right? Because I'm not taking into account those environmentals for the 8 feet between the AP and the floor or the desk where the student's sitting at, or the employee sitting at. But it provides enough information along with all the other analytics and data that we're pulling from the client connectivity and everything to give it a pretty good assessment of what's going on.
And has Nile considered maybe creating a software sensor where someone can install it on their laptop and get further feed information directly from a device?
It's been talked about, Roa, but I'll be honest with you, it's one of those things that I think that we're a little bit gun shy to do it because it turns into yet another agent that somebody's got to deploy and maintain on a device. And how many devices can I actually get it onto? And I can't get it onto IoT devices, right? So it's like one of those things of, will the value actually be there? Will customers be able to operationalize around it? What are the gaps? And instead, why don't we take it the point of view from the infrastructure?
Okay.
Make sense?
Yeah, it does. Yeah,
Hey,
I've
Roel, I
always
know.
found it a challenge.
Oh, the yet another agent thing, yeah.
Sorry.
Hey, Roel, I know we want to. I touched on security a little bit. I wanted to kind of talk a little bit about the security architecture that I've just kind of teased out. Is it okay if we jump into that a bit?
Yeah, go for it.
Yeah. Hey, so if I've talked about complexity quite a bit on this podcast, and if I were to make a poster child out of complexity for the network, it's probably securing the network. All the network access control stuff that I talked about, different segmentation architectures I talked about, doing things like dynamic ACLs and roles and security group tags and VXLAN and DNA and all this stuff, right? Including locking down that config and trying to get the magic config on a port to be able to authenticate users or devices or, guests or whatever. It's crazy complex. I'm sure everybody that's tried to do this has realized how complex that environment is. But the threats haven't stopped. Right? So how do we get to a point where we can actually lower risk in an organization, especially around the risk on the network side of the house? And how do we reduce the spend of all these different tools that they have to deploy, as well as the operational burden associated with them? That was one of the key pillars that we wanted to try to attack and try to solve for customers. What if they can just consume security as opposed to trying to bolt it on? Networks inherently, originally weren't built with security in mind. All of that has been bolted on. And still to this day, VLANs, which were a construct to control broadcast domains, are being overused for security segmentation. Right? So if we think about the problems that customers are dealing with, and by the way, one other, just to pin a finer point on the problem statement, a lot of organizations, as they're going through audit compliance, whatever, because there's such a gap on the segmentation side, the visibility side, who's connecting to the network, how they're connecting, and how am I managing the risk? Cyber insurance premiums go up quite a bit. The cyber insurance requirements to get cyber insurance, as well as what deems or what determines the premiums that a customer is going to pay. 5 years ago, it was one page of relatively loose requirements. Now it's like 40 pages of very strict requirements to even get insurance. I had some customers a couple of years ago telling me that cyber insurance is going up year over year, 100% to 400%, which is crazy. And it's because of the risks and because of the complexity. So we took this approach to say, how can we build zero trust levels of security into the actual stack with zero config, right, to eliminate all that complexity, zero cost where it could actually offset some of the bolt-on solutions that customers had to pay. So we took 3 core zero trust principles and built the architecture to have those built in by default. Number 1 was encrypt everything end to end. Instead of those intermediate links between an AP and an access switch to a distribution switch, etc., being unencrypted, why not encrypt those at a layer 2 level with MACsec by default? Right? So there is no chance that anybody can do a passive or an active scan, where they could do a man-in-the-middle snooping, IP packet injection, etc. Just eliminate that risk altogether. By the way, if you think about setting up MACsec, try to, if I can afford the equipment that has it, and the software that enables it, I've got to figure out the magic config on how to make these network elements authenticate to each other, negotiate multiple keys, and do hitless key rotation over time without dropping a packet. That config in and of itself is complex. The software does it by default, right? The network stack just comes up with that. That was zero trust principle number 1. Zero trust principle number 2 was authorize every connection. Instead of many customer environments still having wide open wired switch ports, just statically mapped to a VLAN and hoping and praying that the right device is going to plug into the right port to get to the right VLAN, to get to the right security policy, why don't we just lock this down? Right? Instead of somebody trying to come up with a golden config to make every port colorless and having to manage that config, why don't we just build the software by default to do that? So we took this approach of no unauthorized connections. Every device connecting wire to wireless has to authorize. The customer gets to choose how they're authorized. Right, the network's already pre-configured and capable to do 802.1x or SSO for user-based authentication or captive portal, to do pre-shared key, MAC off, and fingerprinting for IoT or device-level authentication, to do captive portal, for guest, to do fingerprinting of every device onto the network and using those fingerprint for authorization, to do first-hop security to prevent MAC spoofing, IP spoofing, rogue DHCP, all this stuff. The network's just built hardened like that. Okay, that was step 2. Step 3 was authorize every request. And if we think about that from a network world, that means every flow must be authorized and has to be allowed. Let me go back to the VLAN use as segmentation. If we think about mapping different devices or users based on risk into a VLAN and then trunking that VLAN up to a firewall, that firewall doesn't see anything until something tries to cross into a different subnet, into a different VLAN. That means at the access switch layer, a compromised host comes in, can laterally move to every other host on that VLAN without the firewall seeing anything. And think about the complexity you need to build into the network to stop that. Dynamic ACLs, roles, all this private VLANs, all this other stuff. You could do it, but can you really with all the complexity that exists in trying to do it? What if the network allowed you to segment the way you wanted to segment, but then isolated every host from every other host by default within inside that segment and forced it up to the firewall? So we eliminate that blind spot in the network. We eliminate the VLAN problem. We eliminate the lateral movement problem. We give the best security tool in the customer environment, the firewall, the ability to see, detect, and enforce even the east-west traffic between hosts by default.
And would that work the same way on a Wi-Fi network?
Yep.
Okay. So in the traditional sense for Wi-Fi, they would just do isolation where none of the clients can talk to each other. But most networks would require some sort of communication to, say, stream something to an AV piece of equipment that's probably on Wi-Fi also. But you're saying you could send, even though it's east-west traffic on the same VLAN, you could send that traffic back up to the firewall and have that inspected?
Yeah. Think about if I were trying to do a capture the flag or a pen test or something like that, the first thing I try to do is try to get access, connected. Right? Once I'm connected, I get an IP address. I'm going to start doing a host scan or a port scan to find out what else is out there that I can laterally move to, establish persistence, and try to get some privilege escalation. Wouldn't you want the firewall to be able to stop that traffic? I think most organizations, build their security posture with the concept of assume compromise. I can't prevent everything. I have to assume something's going to get in, which means the game is now detected as quickly as possible before it becomes a breach, and try to limit the blast radius so the cleanup effort, right, is much reduced, compared to having to clean up every host that's in the environment. If I have a segment of one, for all intents and purposes, that enables those security tools to be able to see everything it's doing, I can essentially eliminate the lateral movement, and I can definitely detect things way before it becomes a breach, and my blast radius is one.
Okay, so this is part of the whole zero trust architecture and trying to prevent at least a compromised host trying to compromise other devices on the same subnet. Because traditionally, or how it's done in a lot of networks is, like you said, traffic on the same subnet doesn't hit the firewall. So that's not being inspected until it does try to reach another subnet.
There's typically two types of architectures, before that are implemented before traffic gets to a firewall. One is relatively simple. Smaller networks have VLANs that they're mapping users and devices into, and they're trunking those up to the firewall, and then you have zones up there, right? The blind spot is the individual VLAN. As soon as it crosses the VLAN, the firewall see it, right? There's a separate architecture that's common where I still have the VLANs, but I've got a routed connection between my VLANs where my users and devices are and where the firewall is, right? In that world, unless I put ACLs on that router and try to keep those ACLs up to date and in sync and stateful, and do some type of tapping and malware detection and looking at network traffic for malicious behavior, things are going to be able to cross subnets there because it's routed before it gets to the firewall.
And how do you authenticate wireless devices if somebody wanted to have pretty robust security around their SSID? How would you do 802.1x? Are you guys also providing the PKI infrastructure? How does that work?
So if you think about 802.1x, there's typically three to four pieces that are kind of involved. There is the supplicant config, right, on the clients. There is the network config, and then there's the radius component of it, and then you have the CA aspect of it. And for us, we've built the network where you don't have to worry about the network config. That piece of the complexity and upkeep goes away, but you still have the supplicant and the radius piece that you have to take care of. Today, we are not touching either one of those. We just got rid of the middle part of the complexity, and we can support integrating into any kind of external radius server, ClearPass, ICE, NPS, whatever it might be, free radius, what have you. Okay. But within about 3 months, we're going to be coming out with our own cloud-based radius service, so we can authenticate ETLS connections there. You would still have to upload a server certificate and have your own PKI and everything else. We're not touching that piece, but we can offload, the need for an external radius server. But I want to throw an alternative by you. We have some customers that don't want to deal with those different pieces and parts of the complexity of 802.1x. And, in today's world where SSO has become very prevalent, right? And most users know how to log on to SSO. They're doing it with their applications today. Why not bring SSO to the network layer and treat the network as an application and log on users or identify users via SSO? So we have some customers that are fundamentally moving away from 802.1x and moving to SSO for network-based authorization.
Okay, I haven't
actually. We worked with a customer where we created like a custom captive portal that would essentially allow them to do that. But it's not built in inherently inside the network. It's still a custom portal, but if it can be built in, that would be pretty cool.
Today, it's built in for wired and wireless authentication. No config on the network elements. You go into the portal, and you just basically add your IDP information in there. You basically say, hey, I want this SSID to do SSO authentication, and I want my wired ports to do it. And done.
Okay. And so any IDP supported, or is there an easy button for certain IDPs?
The steps are relatively easy. It's like 2 to 3 parameters I got to put in there, but any SAML 2.0 compliant IDP we could support.
So listening to you on security, wouldn't it make sense for you guys to build a firewall?
It's a great question, Francois. So not yet, but I'll tell you where we are going and where we see some of the trends in the market going. So one thing that I didn't mention, and a typical question comes up when I talk about our security architecture, especially that host-based isolation, is, Austin, isn't that going to kill my firewall? Aren't we sending too much to the firewall? It's going to burn my firewall up, right? Most customers that we've deployed, every customer has asked that question, but most customers that we've deployed, we found that most traffic was going north-south through the firewall anyway. So all we brought to that firewall was visibility into the blind spot that existed at the access switch layer, right? It did not dramatically increase the load on the firewall at all. Some customers have had to, beef up the firewall, but for customers that are really concerned about that, we've enabled a component called Trust Engine, which allows you to build east-west policies inside the Nile service block. So our default is to send everything to firewall, but you can override the default, based on user groups, device groups, app groups, who should be able to talk to who within a segment or across segments inside the Nile service block, and then send everything else up to the firewall. So that helps, like with a camera segment. Hey, if the cameras are only talking on a VLAN or a subnet, and they're only streaming to a server that's on the same subnet, why does all that traffic need to go up to the firewall? It's isolated. So that Trust Engine enables that capability. So that starts to get more policy controls in the stack. It's not a firewall, but it starts to look like something like that, right? The other trend that we're seeing is for customers that have moved their data to the cloud, right? And they've got their critical assets in the cloud. That means they've started to move not only their data to the cloud, but they've moved their security controls to the cloud. Things like ZTNA and SSE, Zscaler, Prisma, Cloudflare, Netscope, all these cloud security type of solutions that a lot of customers have standardized for the remote users. They now want to use those same controls for their in-building or on-prem users instead of having to recreate those policies with firewalls. So we've built integration with those ZTNA and SSE solutions to dynamically build tunnels to the customer's instance of those solutions and use that trust engine, that policy engine, to selectively choose what traffic should go to the local firewall or to the local SD-WAN box or straight out to the internet, what traffic should go through that tunnel up to that ZTNA or SSE provider of choice, and what traffic should be forwarded or switched locally.
Okay.
So it's not a true firewall that we're building yet, but we're seeing a trend for those ZTNA cloud security type of solutions.
Yeah.
And we're building enough policy controls in the stack to allow for some east-west granular controls.
Now, so you're saying that, go ahead, Ro.
Go ahead.
No, I was going to say, if I'm listening to you correctly, you're saying that in the future, we might not need firewalls?
For customers that have, I want to be really careful. For customers that have moved their data and their critical assets to the cloud, right? And by the way, Gartner calls this trend or this market trend campus zero trust. And if you combine it with the existing remote user zero trust, those two pieces together, they're calling universal zero trust, right? So I'm basically moving my controls, centralizing them into one of those ZTNA or SSE solutions. If a customer has moved all their cloud or their critical assets to the cloud and their application to the cloud, and that architecture makes sense, which there is a segment of the population where that architecture absolutely makes sense, then yeah, maybe they don't need the on-prem firewall, right? But I am not saying that the majority of the customers are going to go there. There's still a lot of customers that still need that on-prem firewall.
Yeah,
it would make your job easier. Yeah, because if everyone has all of the application in the cloud, I'm thinking the on-prem network can just be one flat VLAN, and then that's it.
Internet cafe, right?
Yeah.
Yeah.
Well, if I have an internet cafe type of model, go ahead, Furlow.
I was gonna say, if you're gonna, I can see one flat network, but then you have all these IoT type devices that can be easily compromised. But you were saying, Austin, that you could go and inspect east-west traffic on this, any device that might want to communicate with another device, send it to the firewall, and given the challenges of a lot of people working remote with some on-prem, then that's where you're looking at that SASE model where maybe the firewall's up in the cloud and you're sending
it's like a secure internet cafe type model, right? Where I still have that host-based isolation to minimize the compromise from all these different types of devices and users, but I get that granular control and that visibility to either send them up to whatever security clearinghouse I want or to stop them from talking to each other, right? Yeah. And without naming names, we are seeing some very large enterprise customers going that route because that's where the data has moved.
Yeah, nothing's hosted at the office anymore. Everything just needs an internet connection.
Yep.
Well, that's, it's an interesting approach you guys are taking with the network. And I really like the whole aspect of securing devices on the same subnet and then automating a lot of this, making it more simpler. I am running into more organizations where they don't have dedicated network engineers. It's just people who do all around general IT, but they can't spend their time trying to do network architecture. And it sounds like you're trying to solve that problem and give them at least the flexibility of getting insights, but making it just easy to consume.
I want to solve that problem, but also at the same time, and I want to be really clear of this, Roel, this is the amount of complexity that exists in a network stack. I fundamentally believe in being a former CCIE and being in this industry for close to 30 years. I don't know if anybody can really truly keep up with all the complexity that's out there.
Mm-hmm.
So this isn't just a small, shop type of solution where I have no IT staff. Even the network engineers that work for large companies, to me, this is a better tool in their toolbox to deliver the outcomes that their business expects. Even though this gets, bulked into the network as a service type of thing, it's as you and hopefully the audience has heard, it's very technology centric innovation. It's not just a bundling exercise and everything else, and it's a co-managed model. I go back to that cloud analogy, right? If I can give you a technology stack that just works, that has the security, scale, capability, it's always updated, optimized, et cetera. But I give you, the network engineer, the control you need to do what you want to with that networking without without all that burden, right? And I give the visibility you want and need to be able to support your users, devices, and applications on the network, right? Where I could reduce a lot of the issues. I can stop the constant blame game of the network,
Yeah.
right? And I can free up your time to do more with the other cool business initiatives that, the business is moving forward with. This is a tool for the network engineer, for the network operators to help them, deal with all the, the complexity that they're burdened with today.
Awesome. Well, Austin, I want to thank you for joining us here on the ClearSend podcast to really describe what Nile is trying to do. Where can people actually go to find more and maybe try to get their hands on Nile to see how it could help them on their networks?
Yeah, absolutely. So listen, definitely head over to nilesecure.com. Into the resources tab, there's a lot of videos. If you want to hear me pontificate more, there's a lot of videos on there about that. But I would highly recommend for everybody that wants to get a feel for what does my experience look like with this service, with this technology, right? If they go to nilesecure.com, look for the Copilot demo. I think it's Copilot-demo. There is a sign up form. I think we turn around account credentials within an hour. And the demo that I use on a daily basis, which is a live environment with live traffic and injected issues and everything else that I show customers all day, every day, that same environment is available for your listeners to go log on and poke around, right? See what actually their interaction with this technology would be, see the amount of control that they would have over this technology stack, see the amount of visibility this technology stack produces, so they can see what their experience might be with this.
All right. Well, for anyone who has any questions, let us know in the comments. And if you're using Nile, I'd be interested to hear what your experience has been like. Francois, do you have any other questions you want to ask Austin?
No, I'm good. Thank you, Austin, for your time. I didn't know much about Nile, and I feel like I know a lot more about it. So thank you for answering our questions, especially my questions.
No, great questions, great forum, guys. Thank you for having me. I really appreciate it.
Awesome. Thank you. And again, leave a comment down below in the video or on the comment section of the show notes page. We'll include some links as well. Just go to cleartosend.net. You can search for Nile, and we will see you guys on the next episode. Thank you.